2A, section 13.2a is titled dot product. Okay, so one way of multiplying your vectors is to use something called the dot product. Okay, in order to multiply two vectors, you need to have two vectors. So they're going to give you two vectors, and then you're going to multiply them together following this little pattern right here. You're going to take the first value of the first vector. You're going to multiply it by the first value of the second vector. Then you're going to take the first value, the second value of the first vector, and you're going to multiply it by the second value of the second vector. Then you're going to add them together. Make sure you follow that order of operations. Multiply first, and then add second. Like in PEMDAS, multiplication comes before addition. So do your multiplying first, then add the two numbers together. Does that make sense? Okay? So what you're going to end up with is a number, not another vector. Okay? Let's look at one in the next box. Okay? So here are your two vectors. They're called u and v. U is the vector 5, there's a bug, 5, negative 2. V is negative 1, 3. So we're going to take the first value of the first vector, multiply it by the first value of the second vector. I put in parentheses so I remember to do that first. Okay? Then we're going to take the second value of the first vector, multiply it by the second value of the second vector. I put in parentheses so I remember to do that first. Okay? 5 times negative 1 is negative 5. Negative 2 times 3 is negative 6. Then you add at the end, so negative 5 plus negative 6 is negative 11. And if they want you to draw it, this is your first vector. 5, negative 2 would be this one over here. And your second vector, v, would be negative 1, 3 going up there. Okay? Any questions on that? It's pretty easy. All you need to do is basically remember order of operations. Just multiply first, then add second. Okay? All right. Now we're going to talk about a new word for you called orthogonal, but you kind of already know what it means. It basically means perpendicular. So we're going to be determining if the vectors are orthogonal, which is fancy for fancy for perpendicular, if and only if they end up with a dot product is 0. So if you take two vectors, you do their dot product, and you get a 0, then you're going to know that the two vectors are orthogonal. And the other thing is, if u and v are parallel, if and only if their slopes are the same. So we're going to look at 2 in just a second. All right. So down at the bottom, we've got examples of, are they going to be orthogonal? Are they going to be parallel? Or are they going to be neither, neither, however you want to pronounce it? All right. So first, we want to see if they are.
I'm just saying everything went amazing yesterday.
Oh, good.
We got 20.
All right. So we want to check and see if they're orthogonal or not orthogonal. Basically, dot product equals 0. Yes, they are. Dot product does not equal 0. No, they're not. Okay. So you take the first value and the first value, multiply them. Second value, multiply them. Add them together. They're opposites, so they equal 0. So you say, yes, they are orthogonal. Okay. Then you want to check and see, are they parallel? Well, if they're orthogonal, perpendicular, can they be parallel? No. So we should get an answer of no. Okay? But let's just say we didn't know that. We still need to check. Okay? So we're going to go 3 over 2, write it as a fraction. You can sometimes reduce it, or you might just be able to tell that they're not or change it to a decimal and see if their decimals are the same, because on a calculator that might be the easiest way, okay? So that's vector u. Now vector v, we're going to go 4 over negative 6, which gives us a negative 0.666666 in the calculator. So these are definitely not equal, so they are definitely not parallel. Why? Because they're orthogonal, so they're not going to be parallel, okay? All right. Example number 2. First, we're going to check and see if they're orthogonal, meaning their dot product should be 0. So we're going to take the first 2 values and multiply them, take the second 2 values and multiply them, then we're going to add them together. We get negative 75, which is not 0, right? Not 0, so they are not orthogonal, all right? But could they possibly be parallel? They could be, so let's check. We're going to go 5 over negative 10, write it as a fraction or a ratio. Punch it in your calculator, you should get negative 0.5. Some of you can just reduce that in your head, right? And then take the second vector, negative 3 over 6, reduce it. This one would be an easy one to reduce. But again, if you type it in your calculator, you're going to get the same answer here. Same answer, just like when you're comparing 2 slopes of lines. If their slopes are the same, they are going to be parallel. Okay? Any questions on that? No? All right. Awesome.